Custom timing curves are great, but what if you could see those curves and manipulate them in real time? Hello and welcome to CodeSlicing. This is the first part of a two-part series where we're going to be recreating a busy screen. Now, the busy screen itself is interesting, but it doesn't really matter. We're actually going to be creating a custom curve building utility, which will allow you to see your custom timing curves, play around with them in real time and see what the effects are. It's quite a complex project, so that's why I've split it into two, because we've got so much to get through. I wouldn't say that one is more interesting than the other though, so I mean, if you are diving off to see the other one immediately, that's probably a mistake, because there's lots of interesting stuff in both episodes. So without further ado, let's get started with episode 1. Right, so we are going to build a utility that is going to allow us to create custom timing curves at will. And in any project, we can just use this thing and it's going to be able to show us what those timing curves look like, and then we can use it to actually generate the resulting timing curve. Now, everything hinges around the control points in a custom timing curve. I mean, after all, that's what you specify when you use one, which you'll see later on. So we're going to start by defining those control points. And we're going to do it like this. We're going to say, these are state private variables, CP0 is CG point of 0.4 and 0.4. The next one is going to be 0.6 and 0.6. And I've called them CP1 and CP0 because they are defined that way in the call to the custom timing curve. So what is a timing curve? Well, very basically, and it doesn't actually get much more complicated than this, a timing curve is a curve on a unit square that represents change over time. That's it. So we could be talking about an ease in out animation, or an ease in, or maybe an ease out, but they all boil down to the same thing, and that is a way of telling SwiftUI how to animate a given change over a given time, or duration, if you like. And since it's defined over a unit square, this can be easily mapped to any duration and any change. So when we're talking about custom timing curves, all that means is that we're specifying those two control points that define the shape of the curve, so they will be points defined in the context of a unit square. Makes sense? If you want to get more details on custom timing curves and the effects they produce, Mark Moeykens has done a lovely video series on this very topic, so I'll link to that in the description below. For our purposes, however, this should be enough to get you going. Now, our custom timing curve utility is going to be a struct, and we're going to define it like this. Custom timing curve, and that is going to have two properties, and they are going to be our control points. But in this case, they're going to be bindings because we're going to want to change them as we go. We'll say binding var CP0, which is a CG point. And then we have a CP1. Great. Now we're going to want to represent this custom timing curve as a view. That view is going to have 3 layers in it. It's going to have the curve itself, a grid over that curve, and it's going to have a view on top of that, which is going to allow us to manipulate those control points. So 3 layers, perfect for a Z stack. So let's create a function here, which is going to return us our view. Func as view, we're going to pass it in a size, which is actually just going to be a CG float because we're going to be using a square, or at least it's going to represent a unit square. That is going to return some view. We have our Z stack, and we know we're going to need. And then we want to have our shape first of all right? So let's define that shape so we can use it. This one can be a private shape. So it's a custom timing curve shape. And then we can just use it here. Timing curve shape. Now, actually, that custom timing curve shape is going to take our points, but we're going to have to do something to them first. So let's deal with the grid on top, and then we'll get to that. Now, this Z stack is going to have our size. We know that that is the correct size now. On top of that, we can just put our layout guide, which is going to be a grid with 10 columns and 10 rows. And we can just set the environment variable here. Show layout guides is true. We know we want it. And if I resume, we'll see nothing because we haven't referred to it yet. So let's just refer to that here, which is going to be custom timing curve. Now, actually, what I'm going to do is I'm going to set it here. Let custom timing curve is a new custom timing curve, passing in our bindings, CP0, CP1, because I want to use this twice. I don't just want to create it and show it as a view. I want to be able to use it to generate my custom timing curve. Okay, so I'm going to declare it like this, and then I'm going to refer to it in the view. I'm going to say custom timing curve as view, and we'll pass in a size of 200. Now let's resume. It's not liking that because I'm not returning my VStack. There we go. Okay, now let's resume. And there's our grid. Now we want this to be on a blue background. So let's do that. And that is actually going to be a Z stack because we want it on top, and we can ignore all safe areas. There we are. Now that grid doesn't look very good all of a sudden. The good news is that we can control all aspects of how that grid looks. So in this case, we're going to say it's white. Now we can also set the opacity and the line width if you need to, but that is going to give us what we need for now. So let's talk about our custom shape. Okay, let's talk about our curve. We need to translate a unit square into the size of our grid. And there are two problems with that. The first problem is that the Y coordinate for a custom timing curve is inverted. Now, a computer doesn't really know anything about up or down. It's really us humans that care about that. And when we represent timing curves, the standard is that X goes to the right and Y goes up. And the problem is that the coordinate system in SwiftUI, and iOS is that the coordinates for Y increases as you go down, which is the opposite. So we need to invert the Y in order for this to actually make sense to our eyeballs. And we'll keep the X the same, but we also need to scale the unit square up to the size that we're actually going to be displaying. So there are two parts to this, and we're going to define a couple of utility functions to do that. So let's put some utils down at the bottom, and we're going to have one function here which is going to invert the Y of a unit point. Okay, so private func invert Y, which takes a unit point and it returns us a point. And all that's going to do is it's going to say CG point unit point X, which is the same, and 1 minus unit point Y. That's going to give us our inverted unit point. All right. Very important that it's the unit point that's passed in here because I'm assuming that the maximum is 1 there. The next function we need is a translation function or a mapping function. Okay. So let's have a function. It's going to be private func map from unit point. We pass it in our unit point, and that's going to return another CG point. And we've passed in a unit point, so the first thing we need to do is invert the Y. So we say let inverted point equals invert y, and we pass it our unit point. And then we want to scale it. So this is the point where we've got our inverted point. So that is one that is correct for our coordinate system that we want to display it in. We want to scale it up by the size of the grid. So we need another parameter that's passed in here, which is the size. And let's call it 2. So we're going from the unit point to this. So we say to size, and that's a CG float. And then all we do is we say return inverted point scaled by the size. All right, that's it. Because we're going to need this mapping in 2 places, we're going to need it for the curve. We're also going to need it for the shape itself, which is displaying those control points, allowing us to move them around. So we're going to actually create those map points here. We're going to say let CP0 mapped is map from unit point CP0. We pass it in the size that we've just got. The next one, we do the same thing, but for CP1. And then in our shape, we can actually just take those points in. Let CP0, which is a CPG point, and let CP1, which is a CG point. I'm tempted to call them mapped just to make it clearer. In fact, I will do that. Mapped. So in here, when I refer to my shape, I can actually just say CP0 mapped, and we say CP0 mapped. And it just makes things nice and clear. We know that we're passing in mapped points. And remember that shape, we're not going to be adjusting anything in there. We're not going to be modifying those control points, so they don't need to be bindings. They can just be constants. We're just passing them in and using them. Let's return that Z stack so it stops shouting at us. And now we need to draw our curve. Very easy. So we want to move to the bottom leading, which is the standard for displaying timing curves. So we say path, move, rect, bottom leading. And then all we do is we add a curve using our control point. So we say path, curve. We're going to the top trailing. CP1 is actually CP0 and CP2 is CP1 mapped. At this point, if we resume, I don't think we're going to see anything because I haven't actually stroked that shape. So let's do that now. We're going to say stroke. We'll give it a color of white and a line width of 2. And there's our curve. All right. Can't see the control points. Let's fix that. Show control points is true. All right, there are our control points, exactly where we expected them to be. Now, if any of that didn't make sense about the curve and the control points and all of that, then do go back and watch the Layout Guide series episode on Bezier curves, and it will clear all of this up for you, no problem. Right, so we actually have our curve. That is it. And you know, if we move that around, we can see it changing. So if I change that to 0, that is great. So now we have to actually get to the point where we can change them ourselves. That's the fun bit. So let's create our custom timing curve view. All right, I'm going to create it down here. There's our view. It's going to be our custom timing curve view. And that one can be private. Let's not pollute our namespace if we don't need to. In this case, we're actually going to be taking 4 properties. Now we've got the translated points, okay? We've got our mapped control points, but in this case, we also need access to the control points themselves in order to change them, right? So we are quite far down the rabbit hole here, but at this point, when we've got our control points, this is where we actually want to change them. We're going to declare 4 properties, 2 that are our mapped constants and 2 that are our binding control points. So let's do that. So we say let CP0 mapped, which is a CG point, duplicate that and say that's our CP1 mapped. And then we have our binding. Actually, let's just grab them from up here. Right, so we've got our properties. Now we need to display something. The first thing I'm going to do is I'm going to actually just get rid of this, and I'm going to put everything in a geometry reader. The reason I'm going to do that is because we're going to need to read the size. Now, we could pass it in. We could absolutely just pass that in. But I mean, there are a lot of variables coming in, and it's quite a lot of fun using the geometry reader. It's a little bit of practice for us. If you want to pass the size in, very welcome to do that. So we've got our geometry reader, and inside that, we're going to have a Z stack. That is going to contain our 2 points. So I'm actually going to define it like this, frame. And now we want to put in a control point size, which is not yet defined. Let's do that right now. Let's say private let control point size, which is a CG float of size 10. All right, there it is. And now what I want to do is clip circle with stroke. I'm going to give it a black color, line width of 2, and a fill of green. And then I'm going to have another one with a fill color of yellow. All right, so we've got our 2 control points. At the moment, we can't actually see them because we're not using our view. Let's put our view in. Let's be bold. And on top of this shape in our custom timing curve view rendition, we're going to say custom timing curve view. We've got a lot of stuff to pass in here. We've got CP0 mapped, CP1 mapped, CP0 and CP1. Now let's resume, see what happens. Right, that's great. That means it's working. It doesn't look right. Both of those points are there, but they are in the middle. So what we want to do is put them where they should be. And we're going to use, now, if you remember from the MyFitnessPal animation recreation, we used a nice little modifier called offset to position from PureSwiftUI. We're going to use the same thing here, but with a twist. Now, we used the conditional version in that episode. Today, we're not going to do that, but we are going to use one which is specific to a coordinate space. Now, coordinate spaces allow you to specify what your coordinate space is actually going to consist of. Because see, normally what would happen is you would say, okay, so what is my position? What is the position of the grid? What is the offset of the grid in global space? And then how do I offset that to the correct position? But SwiftUI makes this incredibly easy by allowing you to define your own coordinate spaces. Well, talk about cliffhangers, eh? I mean, I feel like we've done so much, but we've still got so much left to do. What have we got left to do? We've still got to do the dots on the graph, get them in the right place. We've got to be able to control them and generate the animations and then see those animations. So still lots left to do. We're going to do it all in the next episode. So join me for that. It's going to be brilliant. If you have any comments or suggestions, please leave them below. But in the meantime, thanks for joining me. See you next time.